The domain and the range. Okay, so what did we say over there? What numbers are the domain? The input, the food, is the domain. So if you had to write it out, you would just write it like this: 2, 5, 7, and 8. Okay, and what's the range? It's the output or the poop. So I would write it as what is here. And it's got to be in order. It's already in order for me: 14, 35, 49, and 56. We're all good with that. Domain and range. How do you remember which is which?
The alphabet?
Yeah. What D comes before R. D is what goes in. R is what comes out. Okay? All right. Tell whether the pairing is a function. Now remember what I said. For every input, there's exactly one output, or only one output. Okay, so is that true? Yep. 2 goes to 0, 4 goes to 3, 6 goes to 3, 8 goes to 5. It's true for this, right?
It says Y. Shouldn't it say X?
Where are you at?
The domain of the function Y. Oh, are we not there yet?
No. Here, let's look at this. Okay. So is this a function? Yes or no? Yes, it is. What you have to only look at is if, say, 4 went to 3 and then it went to 5 as well. That doesn't work. Okay? But 6 can go to 3 and 4 can go to 3. But if 6 goes in twice and poops out 2 different numbers, it doesn't work. Okay? Makes sense? And you'll see that, right, you'll see that here. So yes, it is a function. And then in this table, let's look at what's happening here. These are my inputs. The fishy swallowed 2 2s and pooped out 2 different numbers. Is that even possible? No. The same number can't go into the function and output 2 different numbers. Okay, so this is not a function. It's a sick fish. Okay? 2 put out 2 different numbers. Not possible. Okay. The domain of the function y equals x plus 4 is 0, 2, 3, 6, and 7. So these are my x values. The domain, that's what goes in. Make a table for the function and identify the range. Now I'm guessing you did quite a bit this last year. So here's how I would make this table. X, y, you don't have to do it like that necessarily. And then I would put the function here. Did you do these before?
Yeah.
Uh-huh. And then I'm going to list my x values that they gave me. And then I'm just going to plug in every value for x. So 0 plus 4 equals what? 4. 2 plus 4 equals 6. 3 plus 4 is 7. 6 plus 4 is 10. 7 plus 4 is 11. And then I have to identify the range. So this was the first thing I had to do, and then I had to do the second thing, which was identify the range. So down here on the bottom, yes, Amelia? I'm just going to write these numbers out as the range, okay? The output, 4, 6, 7, 10, and 11. Cool? Brittany, can you put that away? Thanks. Write a rule for the function. All right, now, write a rule means we have to write an equation based on what we see in the table. And that equation we write has to work for every pairing here. So this input is the x, the output is the y. So I have to come up an equation that's going to poop out my y value that works with these numbers. So, anybody have any idea how to go about doing that? Yes, Parker.
Well, you look at the input and the output and see what sign, like addition, multiplication, division, and subtraction.
Very good. So let's look at this pair right here. If 1 went in, 0 came out. So let's look at the next one. 2 went in and 1 came out.
1 plus 1.
4 went in and 3 came out. What's happening each time? It's decreasing by 1, right? So if I put the x in and I take away 1, I should get my y's. Correct? Okay. Very good. Some are easier to see than others. All right. Okay. At a community center, art lessons are offered at night. The fee is $12 per lesson. You plan to attend up to 5 lessons. Pardon me?
I was just saying, who has art lessons
Who has art lessons?
at night?
Some people do, like painting or whatever, sculpture. I don't know. Write the amount you will spend as a function of the number of lessons you attend. So they're saying, how many lessons might I attend? Maybe I'll attend only what? 1 lesson. Or I might attend 2 lessons. I might attend 3, 4, or 5, but I'm not going to go any more than 5. Up to 5 lessons. That's what that means. Okay? Identify the independent and dependent variables, then identify the domain and the range. So let's set it up first. My cost depends on how many lessons I go to, right? So my lessons are going to be my x. So I'm going to say x is the number of lessons. I'm setting it up right now. Y is going to represent my what? My cost. Y is representing my cost. That's my output, depending on how many lessons I go to. Okay, so I might attend 1, 2, 3, or 4 or 5 lessons. So how could I write an equation for finding out how much this is going to cost me? How much is it per lesson? $12. So if I attend 1 lesson, I'm going to do 12 times what? 1. If I attend 2 lessons, it's going to be 12 times 2. So how would I write an equation? 12 times x. Y equals 12 times x. Because x represents the number of lessons. So that was the first thing I had to do. Then it says, identify the independent and dependent variables. And I know you've heard that word before, right? Those terms. Okay. The dependent depends on the independent variable, right? So the value of y depends on how many lessons, x, correct? So which one's the dependent? I think that's easier to identify first. Which one's the dependent? Y. Y is the dependent. It depends on x.
Would the 12 be independent?
No, the 12 is nothing.
The x.
The x is the independent. Independent, okay? So I'm going to say x is the independent. That's not affected by anything. But the y depends on the x, so it's the dependent. Let's list my domain and range. What possible x values could I have here? Remember, x represents the number of lessons, so what possible numbers could that be? 1, 2, 3, 4, or 5, right? Right, you could have any of those. I could only go to 1 lesson, or I could go to 4, or I could go to 5, but I don't want to do more than 5. Okay, if I do 1 lesson, what's the output going to be? 12. So that's one of my range numbers. If I do 2 lessons, what's the output? So you see where we're going with this? 36, 48, and 5 times 12 is 60. That's my range. Cool? Okay. All right, graph the function y equals 2x minus 3 with a domain 2, 3, 4, and 5. Okay, so I'm going to have my x and my y values here. I'm going to put the function in the middle here. Domain numbers, are those my x or my y's? My x. That's what goes into the function, the fishy. 2, 3, 4, and 5. Two times 2 minus 3, what does that equal? 1. 2 times 3 minus 3, what does that equal? Okay. And just for the sake of time, I'll just fill it out here for you. Okay. These represent ordered pairs, don't they? Remember, x and y is an ordered pair. So if x is 2, what does it poop out? 1. There's their first ordered pair. If x is 3, it poops out 3. There's the second ordered pair. You see where we're going here. 4 and 5, 5 and 7. So I'm going to graph these points. But before I do that, I got to figure out what to put here. I think it's pretty obvious what we can put there. Our x values go up to 5. So it looks like I have enough lines just to do that. There's 0, 1, 2, 3, 4, and 5. Y values go up to 7. 1, 2, 3, 4, 5, 6, and 7. Now I know you haven't thought about graphing all summer, but you do the x first, over 2, up 1. X first, over 3, up 3. Over 4, up 5, and over 5, up 7. We're not going to connect them right now. If you did, that's okay, but we'll just leave them not connected. All right. The table shows the profit P in thousands of dollars at a small toy store each year from 2000 to 2004. As a function of time t in years since 2000. So we're starting at 2000 here. I'm going to put 2000. And then we're going up to 2004, just so I can get what that means. What was the profit in 2000? Except it's in thousands, so what? It's actually 19,500, right? Profit at a small toy store. And they went up to 21,800, so that's good. All right, I'm going to graph this. Remember, like, yours is my input, that's my x, and that's my y. Because profit depended on the year, x and y. So this is kind of like, okay, I got to look. I got to put 4 years on here. Am I good with this graph? I can just number it up to 4. Yeah, I think I can do that on the x-axis. But for here, I probably need to go from 19 to 22. But let's just see what I have, okay? Do I have maybe 22 little lines? Can you guys see that? I actually do. So instead of writing 1, 2, 3, 4, it's too small for that. Let's just go up by 5s. Let's go up by 5s, okay? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 15. Can we graph these points now? They're going to be pretty close together, but that's okay. All right, so let's go over 1 and up 19.5. That's going to be right up here almost by 20. And then, oh, I did that wrong. What did I do wrong? It's supposed to be 0, 19.5. So I'm going to cross that one off with the pencil. Over 1 and up 20.3 is going to be a little bit higher. Over 2, up 22.7, about there. Over 3, 21.1. And 4, 21.8, it's about here. So then you can connect these because profit goes on all year. So it's kind of like that. Okay, we're just going to finish this and then we'll be done for the day. What are you saying? What are you saying? Write a rule for the function. Again, I have to write an equation represented by the graph. Identify the domain and the range of the function. All right, well, some of you may be able to just look at the graph and figure it out. Cool, more power to you. What I did was I made a little XY table just to help me see what was happening from X to Y. So this first point is 1, 0. The second point is 3, 2. And then 5, 4. And then 7, 6. So remember, we're going to do y equals, because it always equals the output. What's happening from x to y here for this one? It's going down by what? And then that. Ah, it's going down by 1. It's the same as it was before. So it's going to be x minus 1. Oh, but we're not done. Look, part 2. Identify the domain and the range. Pretty easy, because we already have it listed. 1, 3, 5, and 7 for my domain. 0, 2, 4, and 6.